In this video, we're going to talk about percent composition. So percent composition is the percentage by mass for each element in a compound. So let's take a few examples here to see what exactly that means. So we have a 10-gram sample of a compound that's determined to contain 2.5 grams of hydrogen and 7.5 grams of carbon. So if I want to know what percentage of the compound is carbon and what percentage is hydrogen, I can calculate that as a percentage of the total. So for example, for hydrogen, there are 2.5 grams of hydrogen, and we have a 10-gram sample to start with. So if you divide 2.5 by 10, and then we have to multiply this by 100 to make it a percent. 2.5 divided by 10, multiply it by 100, comes out to 25%. If I do the same thing for carbon, there's 7.5 grams of carbon per 10 grams of the sample. So if we take 7.5, divide that by 10, and multiply by 100, we come out with 75%. So this compound has a percent composition that is 25% hydrogen and 75% carbon. Let's work out a couple more examples here. Carbone is a substance that occurs in two forms having different arrangements of the atoms with the same molecular formula. And we're given the molecular formula here. So one type of carbone gives caraway seeds their smell, and the other type is responsible for the smell of spearmint oil. So we want to calculate the mass percent of each element. Now in the last example, we were given the total mass of the sample. In this case, we're not. See, the other way that we can do this is to calculate the total mass of the substance by calculating its molecular mass, and then we can calculate the percentage of each element. So for example, if we take C10H14O and we calculate the molecular mass of that, carbon has a molar mass of 12.01 grams per mole, and there are 10 of them. Hydrogen has a molecular mass of 1.01 grams per mole, and there are 14 of them. And oxygen has a molar mass of 16 grams per mole, and there's only 1. So if we add that up, the molar mass for carbone comes out to 150.24 grams per mole. So now what we can do, now that we know what the molar mass of carbone is, now we can go through and calculate the percent composition for each one of these elements. Now I'm going to have to erase this so that I don't run out of space here. So I'm going to write the molar mass of carbone up here at the top of the slide. And what we're going to do is, for each one of these elements, we're going to calculate the mass of each element in this compound and divide that by the total mass of the compound. So for example, if we take carbon we know has a molar mass of 12.01 grams per mole, and there are 10 carbons in each atom of or each molecule of carbon, and we divide that by the molar mass of carbon. So what you're going to do is take 12.01 times 10 and divide that by 150.24, and then multiply the answer you get by 100. And if you do that, what you should come up with when you round this off, and I'm going to say for all of these, round them off to 2 decimal places. Since we're not given any numbers in the problem, we don't have a number of significant figures. So to be consistent, I'm going to say go ahead and round these all to the hundredths place, to 2 decimal places. So that comes out to, when we round off to 2 decimal places, to 79.94%. If we take hydrogen, hydrogen has a molar mass of 1.01 grams per mole times 14. And we're going to divide that by the molar mass of the substance. Multiply that by 100 to make it a percentage. So go ahead and put that into your calculator. And what you should come up with is 9.41%. And then for oxygen, I'm going to have to write oxygen over here. We have 16 grams per mole. And there's only one oxygen, so we don't have to multiply that by anything. We divide by 150.24 grams per mole and multiply that by 100 to make it a percentage. I'm not going to write the times 100 since I'm kind of running out of space here. But divide 16 by 150.24 and multiply that by 100. You should come up with 10.65%. So there are 2 more examples here. I'm going to let you take a look at these and determine the percent composition. And then we're going to get more practice with this in class.